Good morning, good morning. Hello, Bear Doodah. Welcome to the stream. I need to turn the volume of... That was my notebook. That's to the left of me. Not this computer capturing the audio. It was maybe a little bit too loud of Discord sounds. And it's nothing for me. All right, leave that there. Let's switch over to the main screen. We're all good and ready to go. So when we left off yesterday, we were in the middle of implementing the flame command so that it spawns that fire in the right position. So if we take a look at this and we run it, we have the partition settings. So basically the idea is that we could do hash fire dash, or I guess we're switching this to a space. So we kind of want to do like hash fire space like 3, for example, and then we want that to show up here. Yeah, that would be really interesting what that would show up, because I think that it will just have it do nothing, or we'll have it do out of bounds. Probably out of bounds, and it'll just say like, hey, that's too big of a number, especially since I'm casting it into a U8. So anyways, we have these messages down here showing that they're coming in. Shoo 83, good morning. Almost missed that. So let's go ahead and see where we are with this. If I remember correctly, we're in this error here. We're returning the error. Yeah, we haven't called new command yet. But when we do command, we can give it the message, and it's going to give us what the command is, which is flame this U8. So we haven't really tested this properly. So let's go ahead and do that. You check the log files to see if to find if somebody wrote to you. I guess I could. That's sort of what happened, was like I missed it in the chat here, but I noticed it in the log. I'm like, oh, wait a second, I missed that. Okay, command went up there. Let's go ahead and now do the thing up here. Okay, so we get the chat message in. Let's go ahead and get the command from that. So command equals command new, and then we're gonna get the chat message dot message. Sort of pass that in there. And you need to be a reference for a string slice. And message string, field of message. Oh, chat message, okay, is private. So that's a problem. So we actually need to go and fix that inside of the, let's see. Where am I getting that from? Okay, I'm just going in a direct path, so I can go directly to it and fix it. So we want you to be public. Fix that. that gives us our command, and let's debug what this command is to see whether or not we've got it. Oh, but we need to implement debug. All right, so let's use this command here. We'll do fire space 3. And I got command is okay, none. Okay, so that didn't work unless it's oh, I'm expecting, okay. So that's clearly a problem. I have flame here and fire in the other one. We should be consistent. Let's make this fire. All right, let's try it again. All right, so we get a sum fire 3. So it actually it brought that out. Now, what happens if I get a let's try that one that Bear was trying. Yeah, okay, so it couldn't, like, I couldn't tell what column to drop into. Perfect. So what I want to be able to do is take this out. So extract out line 19. Was that part of command you wanted? No? Game state. Or are you just testing that it's working? Runs away with your blanket. Okay. I am going to turn this off then. The blanket of lines. Don't be sorry. It's all good and fun and games. It's all good. It's all good. All right. Just easy to confuse me in the morning before I've like finished my tea. First 15 minutes of stream is does this work? Basically, it's like did I remember to turn on all these features? Because if I didn't, then obviously not. But yeah, I did remember to this morning turn it on. So yes. Okay, so what are we doing here? What was happening? Where are we going? We're in the main library. We want to get the command out. Now, if we have an error in a command, I want to send a message back to chat to let you all know what went wrong. Like, why did we fail? So that's why we have that as a string. We can extract that out. So here, I want to make this an if let, and then I think we can do an else. Well, I want to get both, so probably a match is best. So let's do a match on command. So we're going to get the command out. In fact, I don't even know if we need to set this equal to that. So we're going to match. If we have an error, we're going to get the error stir. And I want to send the message. So send to chat is, we have this in the struct right here. So we can just use it. So we're going to do self.send to chat.send. And this takes in, I believe, a string. So we're just going to put the error.toOwned. Of course, we have an OK that gives us the command. So if we have the command, what do we want to do with it? I don't know. Just need one bot to rule them all. Or just lots of tiny little bots that just sort of hope that they don't collide with each other. That's sort of what I've been going with recently. Okay, so command. This is an option command. So we have the result, and then this becomes an option. All right, so I suppose that we do want this to be, let's see, that like possible command. And we'll just put the command out here like that. What are you upset about? Match arms have incompatible types. Because I don't want to return this. I want to send to that. Oh, okay. Yeah, that's a problem. I guess maybe an if-let would be better here. Or I just have to deal with the command all right at this point. Like every time I go with this, I'm never really sure exactly what my my plan is with the match, and I have to like just sort of finagle with the code until I get it slotted into like the right shape and what I want it to look like. Okay, so we have our command, but it's an option command, meaning that I need to unwrap it. Because we have a none, which is no command whatsoever. But if there is something, then we really care about that. If I want to multi-line this. Now send, what do you you return a result. So can I even question mark you? Are you couldn't convert the error to game error. So that's the problem. So I need to properly handle the send. Unwrap is probably not the best pattern for it. I want to be able to handle it properly. Let's see, and then okay. If we get a command, what am I doing with it? I guess right now we're just running the debug on it. And that's that. So that's self-contained, and it works. No, it doesn't work. Mismatch types. Oh, because this is an option. So if I want the option, interesting. So there's okay or. There's take. Unwrap none. I don't want to do that. I want to unwrap it, but if I unwrap it and that will crash, won't it? Because if I do that and it is a none, that's a terrible idea. So I need to then multi-line this, then get so if let some command equals command. Then I want to run debug command. Mismatch types expected. That found enum command. Yep. Semicolon there. Okay. This is not a fun thing, and this is not fun either. So let's go ahead and open up the README. So we have polish, and let's also put in a like clean up code. So things that I want to figure out how to refactor properly is make command nicer. Extracting command in live update is not great. Unhappy face. All right, but this one should allow us to get this out, and if we try to do something that's you know not a right message, we should get the message back. So let's go ahead and try this. So if I do what did we try? Fire like 3. We get fire 3 out of here. That's fine. And if I do fire like 999, I couldn't tell what column to drop into. Okay, perfect. Now that's sending from me, but that's because I have my I'm using the OAuth token for myself. I can change that pretty easily by just going and changing up some environment variables. So perfect. All right, so that's nice. Now if I want to take this command and actually place it onto the stream, onto the screen. What does that really mean? That really means we want to create a new game object and place it into the game object's vector. And that's pretty much it. So we get the command out, and then we test to see what the command is and add it in there. I bet we can create a function at least in here to maybe something like function process like handle command. And maybe this one takes in the option. That might be better. Okay, so handle command, take in mutable self. We want to take in a command, which is the command. We can take ownership of it. Oh, it's going to be an option command. And I think that's pretty much going to be it. We probably are going to need to return a game result. And that should be it. We'll mutate the game objects inside of here. So because of that, we don't need this entire if let anymore. Now we see, okay, we have a command. We're going to run self.handle command, pass it in the command, and question mark that. Okay. Next up, actually handling this command. I guess let's first let's first extract out the command, because we don't need to do anything if there is no command. So let's, I guess, handle that state. So if let some command equals command, regardless of where we go, we want to, at the very end here, just return okay like that. All right, assuming that we do have a command here, I want to then if it's flame, so probably another match off of this command. So match command, if it's command fire, which would then have the index, so like the column. Then I want to create the new game object. So this is really just going to be fire equals game object new, and it's going to take us, okay, where are we going to put this? So we're X. We have what the column is, and since it's starting with 0, we want to figure out, based upon the interface, here we go. We have the single drop zone width. Let's make this public. We either make this public, or I have a function. I like that more. We're gonna have a function in here. So pub function get like the x coordinates. Get interface, like get what column coordinates? By index. So obviously we're going to take in self. We're also going to take in an index, which is going to be a U8. What else do I care about this? I don't think I really need anything else. Because I think it's going to be the size that I really care about. We'll just try this. Then we're going to return. We can just return a tuple with like the x and the y. So this will be an F32 and an F32. Or we can return a point 2, which is F32. Oh, I like that more. All right, so what does this look like for us? Get column coordinates by index. We take in the index. So for example, take in an index like 3, which should return the middle x, y coordinates of the like the drop zone. So what should that be? We know that our single drop zone We have that as an F32. We have the drop zone count. So we want to take our index and multiply that by the single drop zone. And that brings us over by a certain amount. Then we want to bring that into the middle. So what is this going to be? We're going to just return a 0.2 new. For the x, this is going to be the index as F32 times self dot single drop zone width. Then we want to plus half of that. So self dot single drop zone width divided by 2.0. We might need to do some other finagling with that, but let's try that first and see how it looks. Then our y is going to be the halfway down. So self dot single drop zone height. What did I call it? Drop zone height. Divided by 2.0. And we return that. Okay, so now we have get column coordinates by index. So I guess this will be our x and a y. So let's do like drop zone location equals self dot interface dot get column coordinates by index. We'll pass it the column. We're gonna get this drop zone location. That's a 0.32, and then we'll be able to do a drop zone location dot x, drop zone location dot y. What is the draw system for it? An option draw system. Don't we already have the draw system for it? We need to create a new draw system. How did we do it with the flame before? I know we're doing it with flames. Oh, here it is. Draw system is some flame draw system, which we're creating right here. So we can just copy you. All right, so flame draw system, and then our width and our height. What was? Oh, flame size .0 and flame size .1. So we have this entire thing. Basically, we can just copy this. Now, the fact that I'm copying this makes me think that this should be a function. Yeah, that's not the drop zone location. Okay, so paste you. All right, so that gives us that. We get our flame size. Okay, so we're not doing interface. Okay, so this is our X is going to be drop zone location .x. Our Y is going to be drop zone location .y. Add into some flame draw system and then use the flame size that we get out of here. Perfect. So save this. This handles command that this just creates our game object. Let's go ahead and add that in there. So we're going to do self dot game objects dot push flame game object. And that should automatically start going in. Okay, so then cannot find value fire sprite in this scope. Where are you? Fire sprite is a sprite new. Okay, so you can also be copied. Yeah, we definitely want to do this only once because I don't want to have to bring in this image multiple times. It's like literally copying that now gives me 2 copies of the image in memory, which is not necessarily a very good thing. In fact, it's definitely not a good thing. All right, so fire sprite, you need, okay, we need context in here. All right, we do have some errors. Handle command, we're trying to run that. Handle command, we also need to pass in the context. All right, no errors. Let's see if this runs at all. Let's try fire 3. Okay. It shows up with the top left in the middle there. So close. So I need to shift it over by half. And I think we have like the same problem here, I think. We have also, I need to remove the label. Interesting. That worked, but the minus doesn't because it thinks that it's a -1. Okay. And +5, interesting. +5 is a number that's just +5. I didn't think that Rust would handle that, but apparently that works just fine. So let's shift this over into the appropriate spots. Yeah, I don't have it with the ability to read out the messages. Sorry. Not sorry. I turned it off. Let's see. In handle command. All right, so label, first of all, you can become a none. I don't need a label right this second. We might want a label in the future. So flame size, I'm gonna put you. So we have the flame size, meaning that drop zone location Y minus half of the flame size. So flame size dot 0 divided by 2.0 minus flame size dot 1 minus 2.0. I think that'll put it into the center now. Let's try it. Fire 3. Right there in the center. Perfect. Now you're gonna try your fire O. Yeah, no, I'm not turning letters into numbers either. So if I do this, okay, this is putting the flame into the correct position, and I think that's good. If we come to our README here, spawn a flame entity at position 1, or let's try a couple different positions here. So we want fire like 0, fire 9. All right. Perfect. That's spawning everywhere that we want it to spawn. Then, so that spawns the entity. We'll go ahead and save that. And let's go ahead and put this code on up. What is that? What glyph is that? Is that like a little dragon? I'm glad it works. Okay, I'm gonna try to pronounce that. Sinhala letter Taluha Nasikawa Ya. Oh my gosh, I probably butchered that. That's interesting. What does it mean? Or what letter is it? Like converted to English, I suppose. Okay, so this is spawning fire in the correct spot. We'll go ahead and push that up. You have no idea. You just like the way it looks. All right, so I have under bang repo command. You can get a link to all this code if you want to go take a look at it. Just grab random Unicode code for fuzzing. Yeah, that definitely works. All right, back to this. Have the flame entity drop. So we want to implement gravity for our game objects. So what is that going to end up looking like here? We're going to have a velocity going downward. So we have a location, we want a velocity in here. Our velocity can be a, it can be a 0.2. We might as well make it a 0.2. And when we start it up, it's just going to be a zeroed out. Is there like a 0? No. And then when we run update, regardless of what our drop system is, we're also running our children. And oh, we don't need children. We're not using children, I don't believe. So I should refactor that out too. In update, we run our draw system update. Let's also update our velocity. Rizix, good morning. Hey, next project is merging the drop game with this one. Viewers send fireballs. Fireball impact on ground creates a solid block. I hadn't really thought about that. That just actually reminds me a little bit of like that Fall Guys game where you have like the blocks that you're trying not to fall through. If you haven't seen Fall Guys, you know, on Twitch, then obviously that's not going to help whatsoever. But that almost makes me think like, what if we have where like there's a bunch of panels that like I'm standing on, and you're dropping things, and both I'm having to avoid you, but also that's removing panels that I can jump on. So we're seeing how long I can survive on that. That could be interesting too. But all right, so maybe let's do the draw system last. Let's let's update our location first. So we're going to do self dot location. You're a rect. So we're going to do self dot location dot x is going to be plus equals to self dot velocity dot x. Self dot location dot y is plus equals to self dot velocity dot y. So update our location, and then we're gonna draw ourselves. And I want to apply the gravity as well. And so that's gonna be an interesting thing, is the physics. Any streamer audience game sounds like hell to balance depending upon number of interactive viewers. Yeah, I'm not planning on like actually balancing this too much. I figure that as long as it's fun to watch, actually in some ways like the less balanced it is, the better it is, as long as I can survive long enough that it's entertaining. Command-driven chat stream games are definitely smaller stream friendly. I bet we can figure out some ways to like make larger stream chat games, but it might end up going into like those chat plays, like the Twitch plays type games, where it's now a polling, where multiple people have to vote on like what they're gonna do. But I'm certain that there's things that we could do. We just have to like figure out a good design for it. But I haven't done much game design, so it's something I definitely want to learn. All right, so attach channel points to grow, shrink the drop it pedal. I need to figure out how to get and extract the channel points. That's not through chat. Because if you use a channel point thing, I don't think I get a message for that in chat, do I? That's going to be the pub sub or webhooks. So once I implement that, then we can definitely start doing some interesting things with channel points. Bits show up in TMI. Interesting. Okay, hold on. If you're doing something with chat, let me start the game. Oh, it's running, sort of. If I get a message, it'll show up here now. All right, what was I doing? So physics system. We probably need a physics system to now implement gravity, but only for certain things. Like for example, that game object that's in the interface, we don't want that to drop. We want everything else to drop. So we're gonna want a physics system. And then this is gonna be an option that essentially has a physics system in it. Now I don't have a physics system yet, so obviously it's going to complain about that. And then later down here, we're going to do the exact same thing that we have with the draw system. And so that's where this is actually going to be part of that physics system. And in fact, the velocity will be part of that as well. So let's we'll do physics system. It's this option. Not everything will have it. If let some physics system equals then we're going to run update on it. All right. Obviously, this is a problem here because we're not doing that. Game object. Okay, so velocity isn't going to be passed in, but a physics system is definitely. So as part of new, let's bring in a physics system. Okay, so that kind of makes you happy. Now we actually need to create the physics system and drop that in here. So in the main library up here, we're creating the flame game object for the interface. Therefore, we're going to pass in a none for this physics engine, which will make you happy. Except for the fact that I can't figure out what that physics system is. So let's go ahead and add you in. TMI doesn't have any obvious points mechanism. Okay, so that's going to be the pub sub. So we'll eventually get to that as one of our tools that we make. All right, so here's a main library. Let's go ahead and mod this. And into here. Because why would you want to be able to access things equally? Although I wouldn't blame TMI for that. That's a Twitch thing. That's all on Twitch. All right, so what is going to be in our physics system? I'll probably yank what we have in PubSub for Twitchy out to something standalone. If you do that, I would love to be an early beta tester of it. I'll try like implementing into some things. We'll see how it works. All right. Physics system. Let's do. Yank the core TMI reader out already. All right. Need to add a couple things, but if all you need is chat read, good to go. Well, I have chat read already set up, so I need the pub sub. That's the next thing. Okay, so struct physics system. We're gonna have a velocity. This can be an X and Y. There's a lot of different ways we can do this. Let's do a 0.2 F32. Obviously, if we have a 0.2, we need to use GGEZ, algebra, 0.2. We also are going to want to know if we're affected by gravity. So affected by gravity, you're a flag. So this is going to be a Boolean. And I think that's really going to be all we care about right this second with the physics system. So let's impl physics system. So new, we don't really care about our initial velocity, but we do care about, are we affected by gravity, which is a Boolean. We're going to return a new physics system. So our velocity is going to be a 0.2 new. And then we're going to just store in affected by gravity. So then in our main library, when we create these, so new, none obviously comes in here, and that's fine. But in this handle command here, we need to create our physics system. So let physics system equals physics systems new, affected by gravity is going to be a true. And then we're going to pass in a sum physics system. Be right back. All right. So that's there. And then in our game object here, we need to, we're already using super draw system. I think I can remove this and then go physics system. All right, so now this is aware of what physics systems are. We take into physics system, and now it's yelling at us, hey, there's no update on physics system. Let's go ahead and implement that. We can put inside a physics system here, we can have a const gravity, which is an F32. I don't think I can do this as a point 2, so we're just going to say, okay, F32 equals, we'll just do negative 1.0. That's the gravity force. We can even do gravity X for this. In update, we're going to say if self dot affected by gravity, self dot velocity plus equals to gravity X. That's fine, but we need the location in order to update that. So our update also has to take in our location, which, if we remember correctly, is a rectangle. So we need this to be a mutable rect. So use GGEZ graphics rect. Velocity.x. And then after this, we want to update our location. So it's going to be location.x plus equals self.velocity.x location.y plus equals self.velocity.y. All right, so then that updates that. That should be fine. We come back to our game object, which is now yelling at us that we're not passing in mutable reference to self.location. And no errors. Let's see if this works. This doesn't immediately drop, so that's a good sign. If we do fire 3, X is left and right. Y is what we want to update for that. So it works. Just you need to be a Y. You need to be a Y. You need to be a Y. Okay, that would have been better. Now we do fire 3 again. Oh, it's a positive because negative goes down. So you can be a positive number. Let's try this again. Fire 3, and okay, there it goes. Now it drops down to the ground. Perfect. Oh boy. The other thing that we have here, are we limiting our frame rate at all? In our main update? We are. Okay, so we're setting our target frame rate for this, and that will allow us to just make sure that we're hitting like 60 and our numbers will all make sense for us. That's probably a little bit too fast for me to be able to react to. So let's go ahead and set this number to like something a little bit nicer. So like 0.3 maybe. All right, let's try this. You know, 9.3. I don't know. if that'll work or not, no is the answer. Yeah. So fire 3, it comes in and it drops down. Okay, so all right. So that's looking nice. What's next on a README? Maybe make the sprites a little bit bigger. Yeah, we can do that. Have flame entity drop. We could try making the sprites a little bit bigger. I think. Let's see. How do I do that? Let's actually polish. Let's add that for a future thing. Scale up the fire sprite. Yeah, so we can scale it to make it a little bit bigger. Oh, do you just tell them what bounds they fit in and they auto scale? Ooh, that would be nice. All right, have flame entity stop when it hits the ground. So that's going to be the physics system. We need to know where the ground is here. So in update, we need to know the ground location. So we really need to know what the screen height is. And that's going to be an F32. After we update our location, then we want to check to see, okay, so if location.y, if that is greater than, if that's greater or equal to screen height, let's just say if that's greater than screen height, we can do greater or equal to screen height, then stop falling. The easiest way to stop falling is to reset our y velocity to nothing. So self.velocity.y, set that equal to 0.0. And also let's make ourselves no longer affected by gravity. So self.affected by gravity equals false. And that means screen height, we need to hand that in the game object, which means we need that in here. So screen height, which is an F32, and pass that along. Which means in the main library here, we now need the screen size, which we can grab up here. So the width we don't really care about. Screen width, screen height. Oh, you're using a mesh. It's a drawable, so as long as it's a drawable can handle that, then it works. Otherwise, I might need to do something else with it. But yeah, like theoretically, we should be able to do that. And this is going to be graphics, drawable size, hand it the context. We now have the screen height, and we pass that right in here. You can imagine they don't share them. Well, I have it in my polish to eventually get to. So we'll eventually get to it. I can't imagine they don't share them. Okay, so let's try this now, except we have some errors. Expected two arguments, found one. In these children, so this is game object, physics system. So we don't need to have children. So I think I could just, well, we can just update you. Screen height, like that. No errors. Let's try running you. What am I using in Sprite Batch? I am not using a Sprite Batch. I was trying to use Sprite Batch initially, but it wasn't, I was hoping that it was like, I was hoping that it would allow me to do basically a sprite sheet, but that's just a normal image. So I'm just using the image. That did not stop at the bottom of the screen. Or if it did, it stopped below the screen. So I need to have the height. I need to have the height in here as well. So we have the screen height, and I need to have, well, okay, I have this location, which is a rect, which means I have the height of the object in here already. So let's do if location.y plus location dot, I think it's height, h, yeah, it's h. If that's greater or equal to the screen height, let's stop it here. We can also reset its location. Set that, and we'll say location.y equals screen height minus location.h. Just to make sure it sort of like resets into its optimal position. Let's try this. Fire 3. And there it goes. It's now standing, staying at the bottom of the screen. So now we can drop a whole bunch of these. And now they'll just sort of stick here. And I probably want to like make them just disappear after a certain amount of time. So that way I can, the land doesn't eventually just fill up completely with what I care about. But that's a good sign, a sign so far. Let's go ahead, move that over. Stop. Show my draw function. You're already passing draw params. Yeah, so draw function, that's in the draw system. So here's in draw. So we figure out what the sprite is, and then we draw it. Set a scale on draw param, which means I need to know that I have to scale it, because I could create the scale to put into here. That might work. We could do that. Here we can have a scale by, which is an F32, and then in draw, graphics draw param. Here's a dot dest, and then we'll have a dot scale, and this takes in a, we need to store this. Scale by F32. Scale by self dot scale by self dot scale by to make it even left and right. And then what that means is we can now follow the errors. When we create the draw system for the interface, we want this to be a scale by, let's just say like 1.5. And for you, we want you to be a, let's say like 2.5 or 2.0. And that works. So right now, these are what they look like. If I quit, restart. Let's try it again. That doesn't necessarily look any bigger. Is it between 0 and 1? I never remember what the scale is supposed to be. Because I always think it's something like I want to double it, so that would be a 2. But I think it's... I don't think that like 1.0 is... I think like 0 is keep it exactly the same, 1 is double? Yeah, I don't remember what it is. But we'll figure that out eventually. What were we doing? Have the flame entity stop when it hits the ground. We've got that. No, because you can scale smaller or bigger. Yeah. So it's 0 to whatever. Clearly it has to be bigger. If I do do by 20, like nice and big. Let's see, what was next? So you're actually passing it into the draw param and draw. Yeah, so if we take a look at this, here's graphics draw. We have this scale and then scale by in this array here. And so we can see it takes in essentially something that turns into a vector 2. F32, and doesn't really tell me what the scaling vector is supposed to be. Okay, so we have that. Oh, my desk, I'm good. Okay, so what was next? Have the flame entity disappear after 5 seconds. Okay, so is this going to be a physics system? Essentially, I want it to die. So this, I guess we have a life here. So we have a life counter, except I want it to live for like forever if it's a if it's that interface one, and I want it to die after a certain amount of time if it's not the interface one. So maybe this should be something like live count. Let's see, time to live is going to be an option, and an option we can do. This could be seconds, or we can just have this be a duration. We can have it hold a duration. Maybe this should be like a die-at. Live until. Which means that this is actually, I think, an instant. So instant, so use standard time instant. So this is like an instant in time. Instance and duration are compatible, so you can like add them to each other. So what I want to do is essentially, we're going to take in an instant. So when we create a new object, this is going to be live for, and it's going to be an option duration. All right, so we're going to have not only instant, but a duration in here. Live until is going to be, so it's an instant. So there's also elapsed on instant. Ooh, I hadn't thought about that. That might be good. If I do instant, so if I do an instant now, that gives me right now plus, oh, but it has to be this live for. So let's do if, let's see, let live for equals if let sum live for equals live for. All right, so that gives me this duration here. We're going to do our instant now. This is going to have to be inside of a sum too. So sum instant now plus live for our duration and return that. Else return a none. And then live for, this becomes live until. And we throw you in there. All right. Then inside of our update, we have to check to see, are we dead yet? If we're dead, then we want to remove ourselves. Now we can't really do that here. But we can have like an is dead method. Let's first like make this all pass. So you want to create this new game object. We're gonna need a, inside of here, a new live for option. Just on the inside? I'm not sure. I'm not sure what you mean. This is going to be a sum. Actually, this is an interface. So you're going to be a none. Are we dead yet? Oh, just on the, okay, I get it. That took me way too long to get. All right, so we are going to want use standard time duration. All right, so here in handle command, we're going to want a sum duration from milliseconds. How many milliseconds do we want this to live? Let's just make it 5. Maybe like 6,000. That will be like, you know, we'll give it a second to drop and then 5 seconds to live. So if we do that, everything should still work. But now in our update function, we want to, there's also from seconds. Yeah, I know. I'm just so used to working with milliseconds. There is a from secs. and we can do 6, which makes more sense. Yes, I know. Okay, so we have our update. We want to loop through all of our game objects and check to see if it's dead yet. If the duration has passed. So what is that going to look like? In our game object here, usually go for millis too. Yeah, I don't know why. Like, probably just working with so many different languages that use milliseconds, I'm just used to it now. We'll do a pub function is dead. Self. Do we need to know the duration? Because we can get the instant now. Durations in Rust are very flexible. Yeah, that's true. Also, if the duration system doesn't work out, we can easily use a tick system where we say you live for this many ticks. And we can actually calculate that because we're limiting our ticks with to like 60 frames per second. So that's also something we can do too. If this proves not good enough. So we're gonna have this is gonna return a Boolean. So let's first get a now. So now equals instant now. And then we're gonna return if now is greater than self dot live until. Oh, but it's an option. So we really need to do this. Let's see. To do if let sum live until equals self dot live until. Then we get now from here, and we want to return that. Otherwise, return true, false. We're totally not dead. We're never dead. We're immortal. I think I can simplify this check a little, but just having live for duration, birth time, instant now, and check if instant elapsed. Also, Museum, good morning. This method exists, instant elapsed, which passes a duration, which gives you a duration since the instant was created. And I guess, I don't need live until. I need that. I think I can compare an instant, so I don't need to do elapsed. I think it'll sort of do that on its own. I guess they're both instants. So I don't know if I fully need that, but okay, simplify this check a little by just having live for is duration, birth time, instant now, and check if instant elapsed is greater than live for. Yeah, okay, that should right, okay. So if I have birth time here, so we have live until. All right, so what are we gonna do? We're gonna do birth time, and everybody can get a birth time. So birth time is an instant, and then live until is an option. So this becomes a live for. This becomes an option duration. So some things live forever, so they don't have a live for. So live for is an option duration here. This becomes a live for, and then we also want a birth time is an instant now. At one point, Rust was going to have an until API. Ooh, nice. So then, now that we have that, we can come down here and say, okay, if there is a live for, so if we have a live for, we don't have to have this now. Then we want to check to see self dot no, this is going to be just live for dot elapsed. Oh, that's a duration. Hold on. Birth time. Self dot birth time dot elapsed. That gives me a duration. If that is greater, if that's greater than live for, we return that. If live for dot is sum if elapsed live for. Ugh. All right, I think I like this. Let's now go and use it. So is dead. So where is that? Here is it. Here this is. We're doing our update. We now want to loop through each of the game objects. So we want to loop through our game objects and filter out in the case that it's dead. So we're gonna say self dot game objects dot. I think there's a remove. Removes the instance of items from the vector. No. I know there's a filter. Yeah, I guess I need to just filter. Yeah, okay, so we can iterate. Wait, there's a retain. Retains only the elements specified by the predicate. In other words, remove all elements E, such as E returns false. That's what I want. Retain. So do this. And that's why I have it returning false. Okay, so we're going to get a game object. And then inside of here, we're going to do game object dot is dead. So if it's dead, it returns true. Oh, wait. Let's actually change this to is alive. So that way it returns false. It is alive. And then we're going to say is less than. It'll return false if it's dead. And therefore I don't have to have like any kind of not or something. And I think that will cause it to die after 5 seconds. Let's try it. Fire 3. I did 34. Here, Bear Duda, you got it. And it disappears. Perfect. Why didn't I get an out of? Huh. I'm surprised that I didn't get an out of range. So fire 3, fire 6. They live for a little bit and then they disappear and they're removed from the game up. Uh-oh. Hold on. What happened there? This is just gone immediately. Because this needs to be true. It immediately got removed. There. Now it sits there. Oh, look at this. The scaling is working. It's working on the text, but not on the image. That's too bad. But there we go. I might have put it on the wrong thing. You're right. I may have put the scale on the label right there. Let's remove, cut you out. I want to draw. This is draw if that's some label. Where am I drawing the actual image? Because like here's the sprite. If that's some sprite, is that sprite.update? Oh, sprite.draw. So then I want to pass in the self.scale by into sprite.draw. So then I'm going to go into sprites. And in draw, we're going to have a scale by, which is an F32. And then in here in our draw, so our destination, we'll paste in our scale like that. Cargo run. Compile. Oh, we have errors. No field, right. That's because I don't want a self. For you, I want you just to be a scale by. And then you're fine. Let's see if this works. Hey, there it's bigger. Am I coding in Rust? I am very new. Yes, this is Rust, and then I'm using the game engine called GGEZ for this. All right, so let's do fire 3. Oh my gosh. Slightly too big. Just a thought. Just a thought. Maybe just a tiny bit. Just a teensy tiny bit too big. So we scaled by 20. Let's scale by 2. And so now we can do fire 3. And there that goes. Now our math is all a little wrong now because of that scaling. So we have to figure out the scaling ability like for that. But for right now, I think it works. And if we take a look at our README here, how the flame entity disappear after 5 seconds, we've got that working. And so now we have implement the flame command. So save that. Next time we're going to implement the player, which means we need to draw the player out. We need to be able to move left, right. We need to be able to jump. Obviously, we need to be able to stand on the ground too. So player can stand on ground, can help a lot there. And so that's the plan for tomorrow. So let me go ahead, close all these. There's nothing else for me to refactor there. And we have finished first pass through for flame command. So you're using a base unit size and scaling images to that based on the object size. You can look in Stack at Rust for an example. Okay, I'll take a look at that to figure out like how to get the math for that going right. And then we can, yeah, I'm sure we'll be able to get like in size a getter function that we can create that will calculate the new bottom of it. And then we should all be good. So I want, let's see, I'm all good here. That code is all available at Bang Repo. It's the first link on here. And that's pretty much it. I'm doing these streams every single weekday morning at 7 a.m. through around 8:30 or so is about when I end these days. And then I head off to work and go and do that for the rest of the day. I'm also doing tutorial Sundays. So if you want to learn Rust and you're just beginner to Rust programming, then that would be an excellent time to show up. I don't have a specific time in the morning that I start, so follow me here on Twitch to get notifications. And with that, I'm going to go ahead and switch to the ending screen. Thank you, everybody, for stopping by, and I will see you next time.